Okay, picture this. You've got the internet's absolute biggest video platform, a massive pillar of the modern web. Now, imagine it doesn't just crash, but it's literally wiped from the fabric of the internet in a matter of seconds. Welcome to this explainer where we're going to unravel a truly massive digital mystery with incredibly high stakes. We're looking at the exact day a global tech behemoth simply vanished.
February 24th, 2008. YouTube's global availability didn't just dip. It flatlined. We're talking going from 100% to absolute zero. Every single video, every user query, gone in an instant. For around 2 hours, the world's biggest video-sharing giant just ceased to exist on the web. Poof.
Which brings us to a massive, almost unbelievable question. How on earth did one local internet provider in a single country accidentally break the entire world's internet? I mean, how does an action meant for a local audience bring down a tech giant globally? To figure that out, we really need to look at the invisible systems running our digital lives. All right, let's dive into this. Have you ever actually wondered how a video gets from a server on one side of the globe directly to your phone? Well, it's all thanks to BGP, or the Border Gateway Protocol. Think of BGP as the internet's postal service. It routes data between these massive independent networks, which we call autonomous systems, so they actually know how to reach each other. But here is the totally wild part. This entire global routing system, it operates basically on the honor system. It runs entirely on blind trust. So BGP uses IP prefixes to know exactly where to send traffic. Imagine an IP prefix is kind of like a zip code. A /22 prefix, that's a broad instruction, like routing mail to a general city. Normally, YouTube announces a /22 prefix to the whole world. But a /24 prefix, that is way more specific. That's like routing mail to an exact street address. Now, in the world of BGP routing, there is one golden, unbreakable law, the longest prefix match rule. Basically, the router blindly follows the most specific instruction it has. If it sees a broad city route and a highly specific street address route, that specific street address absolutely wins the traffic every time. Keep that rule in mind, all right? Because it's literally the exact mechanism that triggered a global disaster. So the catalyst for this global blackout actually started out as a purely local event. The government of Pakistan issued an order to internet service providers to block access to YouTube locally due to the presence of videos they deemed offensive. To comply with this order, the state-owned provider, Pakistan Telecom, decided to route all local YouTube traffic to a black hole. They were essentially dropping the data on the floor so no one in the country could reach the site. And to make totally sure the block worked efficiently, their engineers used that highly specific /24 instruction. Now, if this highly specific /24 instruction had just stayed inside Pakistan, the rest of us would have never even known. But in what was likely just a simple human configuration error by a tired or maybe careless engineer, this local instruction accidentally went global. Pakistan Telecom accidentally leaked this route to their international upstream provider, PCCW, which is based in Hong Kong. And what happened next is a terrifying testament to the sheer speed of the modern internet. Let's look at the timeline. At 0 seconds, Pakistan Telecom leaks the highly specific /24 route. Because it was more specific than YouTube's own /22 broadcast, the longest prefix match rule automatically kicks in. According to monitoring firms, within just 15 seconds, large Pacific Rim providers switch their routes, and in 45 seconds, the central routers of the rest of the global internet blindly followed suit, hijacking the entire world's YouTube traffic in under a single minute.
I know what you're probably thinking. Wait. Didn't their international provider, PCCW, check to see if this route was actually real? Why didn't they just block this massive false claim before it hit the rest of the planet?
Well, here is the shocking truth about the very foundation of our internet infrastructure. BGP does not verify that an autonomous system is authorized. Period. PCCW accepted the false route and forwarded it to the world because the BGP system inherently assumes everyone is telling the truth. There's literally no built-in verification in the protocol to automatically say, hey, wait a minute, Pakistan Telecom doesn't own YouTube's IP addresses. And this brilliantly illustrates the utter chaos that followed. The entire world's traffic meant for YouTube, which is Autonomous System 36561, was suddenly physically being rerouted to Pakistan Telecom, Autonomous System 17557. I mean, Pakistan Telecom inadvertently created this massive crushing data attack on itself by absorbing all that global traffic. And of course, taking down YouTube worldwide in the process. But YouTube wasn't going to just go down without a fight.
The cyber battle for the world's video traffic officially began at 1847 UTC when the hijack started globally. Engineers at YouTube noticed the massive drop in traffic and furiously raced to outspecify Pakistan Telecom. Over an hour later, at 2007 UTC, YouTube counterattacked, broadcasting their very own /24 prefix. 11 minutes after that, at 2018 UTC, YouTube escalated things even further, firing off an even more specific /25 prefix to try and win their traffic back. Now, YouTube's /25 announcement was highly specific, basically the ultimate trump card under the longest prefix match rule. But it was really only a temporary tactical fix. Why? Well, because many internet providers actually automatically filter out route announcements that are that long. So while YouTube's move definitely helped some users regain access, Pakistan's false /24 route was still relentlessly spreading through the filters of major global networks.
So how did this absolute madness finally come to an end? Well, first, Pakistan Telecom realized their mistake, and they tried to fix it by artificially lengthening their route. It's a BGP technique called AS path prepend. Think of it like making a GPS route look artificially longer so cars avoid it, hoping routers would prefer YouTube's shorter path instead. But honestly, it wasn't enough. The bleeding only truly stopped at 2101 UTC, over 2 hours later, when the upstream provider PCW finally stepped in and manually banned the rogue announcements from their network. Slowly but surely, the false route was flushed out of the global internet.
Looking back at the postmortem of this incredible event, several things became terrifyingly clear. First, this massive global outage wasn't an act of cyber warfare. It was literally just an honest configuration mistake. Yet it inadvertently showed the world's hackers exactly how vulnerable internet routing truly is. I mean, if a simple accident could accomplish this, imagine what a targeted, malicious attack could achieve. It highlighted a desperate, critical need for route filtering and the implementation of a secure version of BGP. So the crucial point we really need to take away from this is that our modern digital infrastructure is built on fundamentally unsecured protocols. The Border Gateway Protocol is deeply, deeply vulnerable. It is incredibly hard for local networks to identify bogus routes, meaning a single local mistake can have devastating global consequences. The internet was designed decades ago, based entirely on mutual trust, and we are still paying the price for that architecture today. Security experts often describe BGP as the twigs and twine that hold the internet together. And honestly, it is a chillingly apt description. The invisible glue holding up our global economy, our communications, and really our entire digital world is surprisingly, terrifyingly delicate. Which leaves us with this final thought. If a single typo by a tired engineer in one country can take down a global tech giant in just 45 seconds, how fragile is the rest of our digital world? What other invisible systems are running on twigs, twine, and blind trust? Thanks for exploring this with me. I'll leave you to ponder that one.